Welcome to this tutorial for a mass spring damper in mobile multi-body dynamics. In about 5 short minutes, you'll be able to generate an animation of the same model that you see on the screen right now. Begin by tapping the Create button. Provide a name to your model. In this case, we will simply call it Oscillator. Give a description of what the model does. We'll describe it as a mass spring damper, which is common in linear vibration analysis. Add gravity to the model as a uniform gravitational field with an acceleration of 9.8 meters per second squared. Applied in the -y direction. Extend the time for the simulation to 5 seconds. And reduce the tolerance, which will make the simulation smoother. Tap OK, then go to the Diagram tab. Before we go further, we will tap the Export button to save our model so we can come back to this point later. We will use the classic interface first to define the kinematics. Create a generalized coordinate corresponding to the vertical displacement, name it h. And create a new vector to which we will attach our generalized coordinate. When we return to the diagram view, we can see the created vector represented by the gray line. Next, create a point which will attach from the origin along the created vector to a new point we will call A, now represented by the blue dot that we see on the top of the created vector. Create a translational spring which will attach the origin to the point A. We'll create 3 parameters with K corresponding to its stiffness, C to its damping, and an equilibrium displacement value. Now we see the orange spring graphic with a damper in its center. Import our previously saved model to start from the beginning, where we will show the simple method of defining that same system using the joints interface. Create a prismatic joint which defines translation in a single axis, in this case using the +y direction. The value corresponds to the generalized coordinate, and this is its initial state. As before, we will add stiffness, damping, and equilibrium for the spring. When we return to the diagram, we can see, as before, the orange spring and blue point at its top. Now, to model the dynamics, create a particle or a point mass. Name it Bob, and provide it a mass value of 1. And attach it to the point defined as A. Our green circle at the top of the spring is our newly created mass. When we tap the button in the bottom left, it will first generate equations of motion, simulate the system, and finally allow us to animate its motion. Enter our report tab, where we can view the constants, the created point with its position, velocity, and acceleration, bodies, loads defined by the translational spring, equations of motion, and plots. The top plot we see here is the position with respect to time, and below it is the velocity with respect to time. Thank you for joining us for this tutorial to build the mass spring damper oscillator. We hope that this helps you learn how to use the application and will inspire you to build models of your own.